This is an FRQ for my chemistry class. When converting from Celsius to Kelvin, we will be using 273 instead of 273.15. Question 1. Calculate the number of mole of hydrogen gas collected. The student collected a sample of hydrogen gas by the displacement of water as shown by the diagram above. The relevant data are given in the following table. Use PV equals nRT to solve for mole, or N. R is constant and it will always be 0.0821. P is partial pressure of hydrogen gas, or atmospheric pressure, also known as ATM, or the vapor pressure of H2O. V is the volume in liters, and T is the temperature in Kelvin. 1 ATM, or atmospheric pressure, is 160 mmHg, and 1 liter is equal to 1,000 milliliters. My work is PV equals nRT. So first you are given partial pressure in mmHg. So you're going to convert that by dividing 745 by 760, and you're going to get 9.80 e negative 1. All of the questions here will be answered using Scientific Float 2 on any kind of Texas Instrument calculator. Next up is volume, and that's in milliliters. So we need to convert that to liters by dividing 90 by 1000, and you'll get 9.00 e negative 2. And then on the other side of the equation, you have N. You have your constant, which is R, which is 0.0821, and 298, which is the temperature from 25 degrees Celsius to Kelvin. Next up, you're going to multiply both sides together. And from there, you're going to solve it like an algebraic equation. And you're going to divide 8.82 e negative 2 by 2.45 e1 to isolate N and solve for moles. The final answer should be 3.60 e negative 3. Question 2. Calculate the partial pressure of O2 or oxygen, ATM, and the gas collected. A sample of solid potassium chlorate, KClO3, was heated in a test tube, see the figure above, and decomposed by the following reaction: 2 KClO3s to 2 KClS plus 3 oxygen. The oxygen produced was collected by displacement of water at 22 degrees Celsius at a total pressure of 754 torr. The volume of the gas collected is 0.65 liters, and the vapor pressure of the water is 22 degrees Celsius at 21 torr. Hint: partial pressure of oxygen is equal to pressure and minus vapor pressure of water. 1 ATM is equal to 760 torr. The work is partial pressure is equal to your total pressure, which you can see above is 754 torr, and you have to get that in ATM, so you're going to divide that number by 760, which will get you 5.73 E5, and then you take your vapor pressure water, and that is at 21 torr. You're going to divide that by 760 to get 7.76 E negative 2, and then after that you subtract this and you get 5.73 E5.